Okay, let's start things off. I'd like to start off by thanking you for taking the time to attend the presentation this afternoon. My name is Lance Zurich, and today we're going to take a brief look at two special curriculum-based sets that Studica put together that are designed for introducing students in middle schools, high schools, and homeschools to the fundamental principles behind mechatronics. Each of these sets are designed for conducting what we would call a project-based class. And this is where students are going to be required to design and build a series of original prototypes, which are all going to be based upon their own research and activities. And each of these sets is designed around standards-focused curriculum, which was created especially for Studica by noted educator and STEM expert, Tom White. So today we're going to start off where so many technology-focused presentations for education seem to start these days, and that's, of course, with the skills gap that exists. Now, when you hear someone reference the skills gap, or when you hear someone talk about the need for better STEM education in the schools, STEM, of course, is an acronym which stands for science, technology, engineering, and mathematics. Well, when you hear someone talk about this, what they're essentially talking about is the urgent need to prepare our students with the background that they're going to need to successfully compete in the job market that they're going to be graduating into. In the employment market that once greeted our grandparents or even our parents, a good work ethic, a strong back, and being able to take direction might have been enough to land a good paying job where many of the technical aspects could be learned on the fly. But now students must be prepared to enter a world that is increasingly focused on programming, automation, IoT, and rapid advances in all aspects of technology. In short, students must be able to demonstrate technical literacy and aptitude if they hope to compete and succeed. And this is, of course, why so much of the emphasis in education over the last decade or so has been on developing STEM skills. Every new advantage that we enjoy, such as the tablets and the smartphones that all of us use daily, all of these things were created because of individuals who helped to make those advances. If you look around, you can see that countries all around the globe, countries like China and India and so many others, have been making major strides in developing new technological advances and in preparing their own students to take place in their own future workforce. Now, here in the United States, we do also need to prepare the next generation of graduates with the skills, the mindset, and the habits that will enable them not only to secure jobs, but also to be part of the next wave of advancements we are going to rely on to stay competitive on the world stage, and of course, to maintain our stature as a world power. Now, as I have no doubt that anyone attending a webinar like this is already in agreement about the importance of STEM and technology-focused programs, we're not going to belabor that. Instead, we're going to move right along to the main topic, which is, of course, mechatronics. Now, what is mechatronics? Well, it's been called the science of intelligent machines. It's essentially a study that focuses on electrical systems, control, and mechanical systems, robotics. It focuses on the Internet of Things and also on computer science. All extremely important subject areas for students to be exposed to, and all skill sets that are highly prized in today's technology-focused market. But just how highly prized are these? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. So not too bad. So the dilemma is that while, of course, the students who go on to secure these prized career positions, the ones who prepare themselves by pursuing the proper post-secondary coursework, they do need to start developing these habits and this career focus as early on as possible. You would hope in high school, if not even in middle school. Now, the dilemma for educators, and this is an educator, whether you're in the classroom or the homeschool environment, the dilemma is finding ways of introducing this type of subject matter to students in a way that gets them interested and involved in the learning process, and not just memorizing obscure facts or ideas just for the purpose of taking a few tests and then promptly forget them. No. To best help students to really be successful and to really encourage them to consider pursuing further education in subject areas like this, educators need to be able to present this material in a way that makes it relevant, which of course means answering the eternal question that you'll get from students, which is, why do we need to know this? But it also needs to be engaging in a way that holds students' attention much better than rote textbooks and lectures and things of this nature that we'll do, and also something that has visible real-world applications and where the students can get involved in doing things hands-on. Now, it's with this dilemma in mind that we created the Studica Mechatronics programs. These two special sets, one of which is designed as an introduction to the world of mechatronics, and one of which is intended to be essentially a standalone class dedicated to this subject. These sets were created to provide all the materials in one place that educators would need to enable them to offer a project-based class that is relevant, that's engaging, that's realistic, that's hands-on, and which is crafted to meet the most current academic standards. Each of the two Studica Mechatronics program sets comes with its own detailed day-by-day curriculum document, which again was created especially for Studica by noted educator and STEM expert Tom White. The curriculum itself comes as a downloadable PDF, which is available for free with the purchase of each set. This curriculum is designed to align to the most widely accepted academic standards currently in place in the United States. The curriculum is also designed for offering a project-based learning program. And again, this means that solving the problems that arise in each unit requires the students to be actively involved in the research, the design, and the trial and error experimentation and activities, as well as the building of actual working prototypes that will provide the required answers. And students aren't going to be asked to do this alone either. They're going to be asked to work in small groups or teams of 4 students each. This is going to help to develop the soft skills that students also need, maybe just as much as they need to develop technical skills. And of course, by soft skills, we mean things like communication skills, teamwork, adaptability, problem solving, and leadership. And finally, with the exception of some very affordable programming software, each set includes all the physical building materials each group will need to enable it to address all of the design projects presented throughout the course of the curriculum. The curriculum is designed to enable teachers of all backgrounds, even teachers from non-science or non-technology focused disciplines, to have the information they need at hand to properly prepare them for conducting the activity and to increase their comfort in presenting this material to their students. The curriculum is designed to be clear and easy to follow, providing a clear roadmap for student learning. Various supplemental materials are included both in link form throughout the curriculum and also at the end of each unit. There are also special tutorials on familiarizing students with the building system they're going to be using to address the projects presented in each of these units. The units in the curriculum are designed as a series of projects. Each of these projects is presented to students in the form of an engaging real-world style scenario where students must work together in small teams. Again, these are teams of 4 students per group to create a solution to the problem. The project units each contain embedded academics. At the end of each of these units, the students are going to be required to make a formal presentation of the prototype they have created to address that particular unit's real-world scenario and explain the reasoning behind why they constructed the prototype that they did and methods and what have you. There's also a technical literacy task driven by each of these projects. As students work to address each project, they're going to acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are acquired through the carefully designed enabling activities. Again, as required by each project, students will be asked to create original prototypes. They're going to be asked to create any required programming-based solutions and also to maintain detailed documentation during the entire process. Now, as I've mentioned a few times during this presentation, the curriculum that accompanies each of the Mechatronics program sets was created especially for Studica by a man named Tom White. Tom, of course, is the gentleman you see on your screen now. Tom is a noted educator who's been involved in teaching STEM and technology since the 1970s. He's known for designing programs for educational institutions as well as for industry. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. The standards addressed in the Studica Mechatronics programs are the most widely accepted standards currently in place in the United States. These include the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K-12 and the standards for technological literacy. And as I mentioned earlier, the programs are designed to be project-based. So when students ask, why do we need to know this? It's usually because the subject matter that they're being presented with might come across as too abstract ever to be useful in their lives. Instead, with this project-based approach, students see firsthand why these things are necessary and where they are useful. The concept of working in these small groups to solve the project problems will help students to develop the high-demand soft skills that employers look for. These are, of course, things like communication, analytical skills, quantitative skills, flexibility, adaptability, and, of course, problem solving. In this project-based format, all of the subject matter is integrated. The math is integrated with the reading and the writing and so on, which is, of course, ideal for STEM education. Also, because of the manner in which students must approach each of the projects being put forth in the curriculum, again, with the research, the testing, and the group give and take, just to give a few examples. Because of this, it allows for a much deeper exploration of problems than traditional teaching methods might normally allow. The projects presented in each unit are also designed so that if you have several groups working on the same project, you should see variations in their prototypes and the solutions that they're going to come up with. Now, this, of course, can be because of differences with creativity, differences in research, or the different approaches taken by each group. But in any case, students get to see firsthand that problems can have many different answers, and that often there is not only one right answer. Each project in the curriculum presents students with the opportunity to plan, to organize, and to conduct research. The enabling activities that students are asked to engage in provide them with the skills and the knowledge that they need to draw on to complete each project just in time. And students are going to be required to do extensive research as they complete these projects, research that is utilized in the design, the prototyping, the testing, and evaluation and redesign phases of each solution. Once again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough materials for teams of 4 students. This team approach, as stated before, will help to promote soft skills, again, things like communication, the ability to work well with others, and leadership. And the sets also offer an easily scalable approach. Just divide the number of students in your classroom by 4 to determine the number of sets needed for each class. And once again, everything you need to conduct these programs, with the exception of the programming software I mentioned, is included inside of each box. Access to the free curriculum download is included with the purchase of each set. Also included are all of the building materials which students will use in the creation of each of their prototypes. These materials are taken from the unique Fisher-Technic building system, and among the components included in each of these sets are 2 robotic controllers, such as you see on the screen now, and power supplies. And this brings up the question, what is Fisher-Technic? Of course, as many of you may not be familiar with Fisher-Technic, I'm just going to provide you with a little bit of background. Fisher-Technic is a flexible and innovative construction system. Now, unlike other popular construction sets that are designed with the idea of simply stacking, Fisher-Technic was created with more of an engineering mindset. What I mean by that is that the core building block in the Fisher-Technic system is unique, and that it allows attachment from all 6 of the sides. And because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place using a tongue and groove assembly method. And the system also includes a wide selection of very specific parts, such as variations on gears, on girders, various sensors, and so much more. And because of this, it will allow technical builders to address equally specific design challenges. Fisher-Technic was created back in the 1960s by German inventor Arthur Fisher, who was noted for countless innovations used in both the construction and the automotive industries. Mr. Fisher, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fisher Technic, Mr. Fisher was the inventor of synchronized flash photography, and that was back in 1949, as well as being the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fisher Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction, as well as components used in automobile manufacturing, and they also provide consulting services related to high-end automated processes. With all of that said, let's begin looking at each of these two individual sets. And we're going to start off with the Studica Introduction to Mechatronics Program set, or if you happen to like acronyms, you could refer to this one as SIM. The set is designed to help provide a well-rounded introduction to the core concepts of mechatronics. Each set includes access to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, written by Tom White. This curriculum contains enough activity and material to fill approximately 45 academic hours. Now, with this in mind, we recommend this program set for insertion into regular related class activities. It could also be used as a short class unto itself. It could be used for an after-school program, or of course for homeschool use if you wished. Again, the curriculum created for this set is standards focused, using the academic standards most widely recognized in US-based education today, and it's designed for offering a project-based learning program. The set is designed for use in middle or high school classes, or again for addressing these same grade levels in a homeschool environment. The set contains a collection of over 700 Fisher Technic building components, and this will include everything from gears, wheels, axles, blocks, sensors, and so much more, as well as, again, 2 robotic controllers and 2 power supplies. The only additional thing required will be the robotic controlled software, which we are going to discuss later in the presentation. But everything else is included, and you're basically ready to go with that. The curriculum for the Studica Introduction to Mechatronics Program set consists of 6 project units, and they are as follows: sketching and documentation, simple machines, mechanical systems, basic electricity, the conversion and the storage of energy, and an introduction to control systems. And there are also activities included to address the following topic areas that come up during the course of the curriculum: sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flow charts, using the software and the robotic controllers, working with sensors such as the digital switch and the digital photo transistor, working with both open loop and closed loop programming, learning about digital branching, learning about analog sensors such as the photocell LDR, learning about analog branching, working with analog sensors such as the NTC resistor and also the potentiometer. Now, before we go further into the structure of the curriculum, we're first going to double back and look at what's covered in the second set. Now, the second set is titled the Studica Teaching Applications of Mechatronics Program Set, or again, if you like to use acronyms, you could call this one STAMP. This set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. The set comes with access to a free downloadable 400+ page curriculum document entitled Mechatronics Applications, again written by Tom White. The activity material in this curriculum document, when used in conjunction with the contents of this set, is designed to fill approximately 180 academic hours. So essentially, we're talking about 4 times the amount of academic hours as were covered by the previous set. Now, as such, this can really be thought of as more of an expansive version of the material being touched upon in the previous set. And this is really designed for those educators who are able to dedicate a daily class period of approximately 50 minutes a day, 5 days a week, or the equivalent, every week for a full academic year. Again, the set is designed for offering students a standards-focused, project-based learning experience, and it's designed for use in middle school, high school, or again, for addressing similar grade levels in a homeschool setting. The materials in this set consist of a selection of over 1,200 Fisher Technic building components. And once again, this is going to include a wide assortment of gears, blocks, sensors, axles, other pieces, as well as 2 robotic controllers, and again, 2 power supplies. And again, the software is required for this set, and we're going to talk about that at the end of the presentation. There are twice as many project units in the Studica teaching applications of Mechatronics program set as with the set that we previously discussed. And these include units on the following: sketching and documentation, simple machines, mechanical systems, basic electricity, and this is followed by project units focusing on the creation of a garage door, the creation of an elevator control, an automatic pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, links are provided to tutorial sections and activity materials for students to utilize. And this is going to include sections on the following: sketching, linkage diagrams, schematics, Ohm's law and power, flow charts, using the software and the robotics controllers, working with open loop programming, working with sensors such as the digital switch and the digital photo transistor, working with closed loop programming and digital branching, learning about logic gates and combinational logic, edge trigger versus level trigger, learning about pneumatics, variables, positioning, recording positions, creating a graphical user interface, and analog sensors such as the photocell LDR, the NTC resistor, the potentiometer, and working with data. Now that we've taken a look at how each of these sets differs and the specific subject matter that's being covered by each set, let's now look at exactly how the curriculum itself is structured. Both versions of the curriculums share the same format when it comes to the structure of how the project units are presented. And as already discussed, each version will include tutorial materials, activity materials, standards, and supplementary materials. Now, in each case, the curriculum is also designed to be turnkey. And what I mean by that is that each unit is designed to clearly spell out everything that's going to be addressed, and again is going to provide tutorials and other information as the topics arise. Now, this was done specifically to enable teachers from all kinds of backgrounds, and that includes those teachers who may come from a non-science or a non-tech focused background. Again, this was designed to enable them to quickly become comfortable with delivering the material simply by reviewing each section before they present it in class. Each unit presented in the curriculum for each of these sets will touch upon the following sections: an introduction, the purpose of the project will be provided, the concepts will be addressed, an outline will be given, all of the standards are spelled out, there are assessment rubrics, the essential question is put forth, as is the student scenario, once again, a real world style scenario. There's a daily plan, there are vocabulary words and terms, and there are resources. So now we're going to take a look at each of these sections a little bit closer. Each unit starts with an introductory section and the purpose of the project. Just as you would likely gather from these names, this is the section that provides a brief description of the topic that we're going to explore in the coming days and activities. And it also seeks to clearly spell out to the students why they're learning this material and why it's important for them to know. The next section, concepts, focuses on the main concepts to be addressed in this unit. And these can be thought of as the broad ideas that are going to be explored in the unit and the core information that students should take from this project that will be essential for them to understand and utilize, not only today, but also hopefully to draw upon as they move forward in STEM fields of study and if they choose to pursue it further in STEM related careers. Following this, we encounter the outline. In this section, we drill down more specifically to what will be addressed in this particular unit. Now, as the example shown on the screen right now is taken from the unit that addresses aspects of programming, you will see that we touch upon areas such as the methods for writing programs, things like flowcharts and word problems. You have things like program characteristics, as you heard me mention, open or closed loop programming. You talk about branching here, such as digital, analog, subprograms, so on. The next section of each project unit focuses on the specific academic standards that are going to be addressed in that unit. As you will see, this includes the college and career readiness math standards, the reading standards for literacy in history and social studies, writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for grades K to 12, and the standards for technological literacy. Each project unit also contains rubrics, and these are going to include both the rubrics for the specific project being covered, along with general rubrics for literacy tests. Next up, we find the essential question. And this can be kind of thought of as the big picture question that will be focused on in each of the smaller individual activities, and of course, all the aspects of the larger project which students are going to be asked to complete in this section or unit. The student scenario is where the specifics of the project to be addressed are finally spelled out. This is presented in the context of a real-world style scenario where students are presented with a problem that needs to be solved with the creation of some sort of device, machine, mechanism, what have you. And as I've mentioned before, students are going to they don't have to do this alone. They must work together in small teams to craft their answer to this challenge. Now, solving this problem is going to require each team of students to work together to design a unique and original answer, which once again will usually be in the form of a working prototype along with whatever programming may be required. Now, just to provide an example, if you look closely at the student scenario that I'm showing on the screen right now, you will see that the project in this unit has each group of students take on the role of a design team employed by a firm that manufactures garage door openers. Now, in this particular case, students are being required to design a specific type of control system for a new line of garage doors. Here, the manufacturer's requirements are all spelled out, such as in this case, the use of limit switches, meeting certain safety codes that require a method for sensing if anything is in the way of the closing of the door, and also the incorporation of an automatic light. Now, again, each team of students will be tasked with creating both a unique and an original prototype. In this case, it's of course going to be a garage door opening system. And they also have to create the programming needed to control this prototype. Now, as students move through the challenge being put forth in the scenario, each of these teams will be required to document the entire process, both in a design notebook and also in a digital engineering journal. And this means they're going to have to notate all the research being performed, all the trial and error experiments being conducted. They have to keep copies of all design sketches, any revisions they make, and so on. And at the very end of each of these project units, each of these teams of students is going to be required to make a formal presentation in front of the class, during which they're going to be asked to demonstrate their prototype and the programming in action, much as they would be required to do for an actual employer or client in a real world style environment. In the next section, we encounter the daily plan. And this is essentially what spells out clearly, both for students and teachers, what's going to be expected of the students, how the teacher is going to conduct that day's classroom activities, and what specific subject matter is expected to be covered. Now, you'll see some days may involve discussions, other days may focus more on research or building small projects that will help provide the building blocks that students are going to draw on to complete their larger projects as described in the student scenario, But in short, you can really think of the daily plan as acting as kind of a roadmap designed to keep everyone, both students and teachers, on the same path. Now, you will see too that along the way, as different aspects are addressed in each day's activity, such as, for example, if we discuss what design notebook, or if we talk about how to use control software, or working with the controller, or what have you, or flowcharts, whatever, that as these things come up in the text, there are links to sections that will provide further instructions and background information on each of these areas. At the completion of each unit, after the last day of the daily plan, there's a section containing vocabulary. And these are essentially important words and terminology that are introduced during the project unit, as well as a selection of useful resource materials. Now, the resource materials can contain a mix of different types of things depending on which chapter we're looking at. Sometimes it's going to be carefully vetted websites and video links. It could even include PDF documents, PowerPoints, and much more. Besides the project units, each of the curriculum downloads also includes a special tutorial section designed to educate both students and teachers on how to use the Fisher Technic Building System. Now, this includes information on how all of the parts fit together using the pin and groove assembly method I mentioned. It talks about how to identify the different types of parts that are used, from the various types of girders and blocks to working with different types of axles, gears, rivets, and much more. And in this section, students also get to build a very basic sample model just to help familiarize them with the system before they move on to the larger projects being presented in each of these units. And as learning about and maintaining proper documentation is one of the areas that we stress in the course of the curriculum, there is also a section which details just what defines each of the type of documentation that you see listed on the screen right now, and what the students are going to be required to provide for each of those things. So if they need to know, what do you need to have in a design brief, that's going to be spelled out. Or what do you need for a project management plan, that will also be spelled out. And as the process of conducting these types of more open project-based class activities may also be new to many teachers, there is also a section that discusses project-based STEM education and its benefits. And that completes our overview of these two sets. So with that done, let's quickly review the contents and purpose of each set, but this time we're going to do it with pricing. First up, we have the Studica Introduction to Mechatronics Program set, which again is designed as a standards-focused project-based introduction to the core concepts of mechatronics. Again, this includes the highly detailed 242-page curriculum document entitled Mechatronics Fundamentals, written by noted educator and STEM expert Tom White. The curriculum here, when used in conjunction with the building materials in this set, will provide teachers with enough activity material to fill approximately 45 academic hours. It's again designed for those educators who wish to offer a shorter form class on this material, who want to use it in a larger class where it can be part of it, to use it for after-school programs, or of course for anyone who's doing homeschool use. This is perfect for that as well. The teaching materials designed for use specifically in middle schools and high schools, as well as by homeschooling parents seeking to address mechatronics for these grade levels. The physical materials in this set include a selection of over 700 components, including again blocks, gears, sensors, axles, rivets, and much more, all taken from the Fisher Technic Building System, as well as 2 robotic control units and 2 power supplies. These materials will again be used to construct the mechanical prototypes that are addressed in each project unit of the curriculum. Software is again required, which we're going to talk about in just a second. Again, each set is designed for use by teams of 4 students at a time, with pricing starting at just $699 for a single set. But that said, discount classroom pricing for groups of 20 students and up is available by quote upon request. Next up is the Studica Teaching Applications of Mechatronics Program set, the STAMP set as I've called it. Once again, this is designed as an in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics, which is based around a highly detailed 400-plus page curriculum document entitled Mechatronics Applications, written by noted STEM expert Tom White. When used in conjunction with the building components included in this set, the curriculum is designed to provide enough activity and material to fill approximately 180 academic hours. This set is designed specifically for those teachers and homeschoolers who are able to dedicate a class period of 50 minutes per day, 5 days a week, or the equivalent, to this subject for a full academic year. Once again, this set is designed for use in middle schools and high schools, as well as by homeschooling parents seeking to address mechatronics for these specific grade levels. Each box contains an assortment of over 1,200 components from the Fisher Technic Building System, again, blocks, girders, lights, sensors, axles, and much more, as well as 2 robotic control units and 2 power supplies. Required software we will talk about in just a minute. Once again, each set is designed for use by teams of 4 students at a time, with pricing for a single set starting at only $799 per set. And again, discount classroom pricing for 20 students or more is available by request or available by quote upon request. And as I've mentioned before that software is required, let me address that as well. The software in question is Fisher Technic RoboPro software, which is graphic programming software. And when we talk about graphic programming software, it means it's a flowchart style design using various icons which students arrange and link to create the programs used for each model. This graphic programming software is ideal for teaching the fundamentals of programming to all users. Now, normally this would have been something we sell you, but as of this year, this is now available absolutely free for download from the manufacturer's website. That's www.fishertechnic.de. So this is now a free download and you're free to use it then. So normally I would take questions over here. I see that it doesn't look like we're going to have any questions today. So basically, if you're ready to take the next step, for example, if you'd like to request a quote, if you'd like to speak to the dedicated educational representative that's in charge of your state, if you'd like to find out anything else about these two sets or any of the other educational solutions that we offer here at Studica, you can simply call us toll free. Our number here is 888-561-7521. Of course, if you prefer, you can also email us directly at info@studica.com. But if you do have any specific questions about anything I've talked about today, any aspect of the Fisher Technic building system, or any aspect of anything Fisher Technic related, you can also email me directly. As you see, my email on the is right up there on the screen. It is lance.zurek, that is lance.zurek@Studica.com. So on that note, thank you very much for taking the time to attend today's presentation, and we very much look forward to speaking to you soon. Have a great afternoon.